morning, everybody. And it's good to see all the people who have found a way to this session. Some of you queue in the registration queue. We're going to start this session with a speech that I will give you. My name is Karel Eloot. I'm a senior partner in McKinsey & Company. I'm based in China, which, of course, for mining and for metals is a very important part of the world. And then after the introduction that I will give, we will have a panel discussion. And hopefully, we can make it as interesting to you as the industry is these days. So let me get to it. I want to start with this overview. This is an overview of materials worldwide, globally, for the last 20 years. And what you see there is the revenues over time. It's quite obvious that there is a very, very strong increase. There is a 6% annual increase of revenues. And then you see also we have done a breakdown. The lighter blue there at the bottom is metals and mining. And then you have also building materials, you have pulp and paper, and you have plastics. We're in 23, an 8 trillion materials industry, with 1.7 trillion of EBITDA. And you see also that the metals and mining part has actually been growing faster than the overall materials. Right? In total, if you want to put this as a percentage of global GDP, we're talking about 7% of global GDP, very significant part. Now, if you then deep dive into the metals and mining part, right? So the bottom part of the previous chart, you can see that like 7 materials, the whole steel value chain, which I have here as 3 materials, thermocoal, and then copper, gold, and aluminum, they are representing in total 80% of these revenues, right? So this means that if you think a little bit at the right side, where we talk a lot, the battery materials, this is actually a relatively small part of the revenues, but obviously, we're talking about energy transition. This is a very important part of the energy transition. Also graphite, for instance, relatively small revenues in the bigger scheme of things, but very important for what is happening. There's 3 macro drivers that are behind the growth that we've seen, especially over the last years, and also further into the future, are going to be pushing us. Number 1 is at the demand side, right? There is still a growth globally of the population, right? So until 2040, we will have another 10% total growth in population. But more importantly than that 10% growth in population is the 30 to 40% increase of the middle class. Middle class across the world is growing, and because of that will also consume more. So that's a big driver at the demand side. Then obviously the net zero transition has both a demand impact but also a supply impact, right? Demand is, for instance, the fact that we need to do some reconversion from where we are with our old energy to new energy. This means also that, like, for instance, the battery materials are coming into demand, but also for steel, for instance, also some traditional metals get higher demand from some of the new applications. If you think about like offshore wind, has like 6 times more material demand than the traditional energy that it replaces. So demand is also being pushed, being fueled by the net zero transition. And of course, the supply, we need to get battery materials, not so easy. Also copper, we will talk a bit about that. Customers are asking for it. Of course, governments are also looking into it. this requires, at the supply-demand side, definite initiatives. And then geopolitically, and I think in the panel we will go a bit more into that, but geopolitically we all know that the world is complicated, right? And that we need to scale. Scale is needed for a faster energy transition. But where there is scale, for instance, in China, it doesn't necessarily travel the whole world. And then other parts of the world are trying to get scale. So this is geopolitically a complicated supply setting. When we're talking about the materials in the energy transition, we are typically talking about the materials trilemma, which is we need to get availability of materials at an affordable price, and it needs to be also sustainable or needs to be green. These three objectives will need to come together in how we are further developing the materials industries. Now, if you look here, this is a very agile and dynamic space, right? And what I try to do here is to look at when we were in 2020 and we were forecasting for 23 for nickel, for lithium, for copper, where the supply would be. You can see there the blue line. That is our base case scenario that we predicted in 2020. And then you have the white line, that is the actual realization. So you see that for nickel and lithium, the supply that came on stream was actually higher than anticipated. What that means is that there were certain announcements made, but there were other things that were not announced, that we were not aware of, that actually have, in a very agile, very dynamic way, come on stream. Interestingly, in copper, it's actually the other way around. We haven't been able to get to the base case of supply. And actually, that's not a surprise, I would say, because if you see in copper what has happened with the processing costs or the processing prices, the treatment and refining prices, you basically see that it went a lot down because the lack of availability of copper ore. So very agile space where a lot is happening very quickly. And if you look at this in more details, here I'm explaining what has happened actually between what we had been forecasting and then what in reality happened. So I'm breaking down the changes that I showed you on the previous page. And so you can see that especially the new assets that were previously unknown, that were not announced, that in 2020 we were not seeing to come on stream or online. You see there for nickel and for lithium that this is quite significant. And I have also put there the ownership. You see that in lithium, for instance, 2/3 of the extra assets that came as a surprise are Chinese owned. And so what that means also, and again, it's not a surprise, is that the Chinese ecosystem, the Chinese collaboration between different companies can actually do things quite quickly, faster than historically we would have thought based on the projects that we have seen. So there is a certain acceleration happening, but only when there is that ecosystem, for instance, the Chinese ecosystem. Chinese ecosystem not just in China, increasingly also in other parts of the world doing this. Yeah. In copper, you see that kind of positive surprise did not happen. There we have more a traditional situation where we are like more negatively surprised, where we have implementation challenges, right? You see there the change in utilization, unrealized projects. So there is a real challenge there in copper. But in nickel and in lithium, we have the opposite, right? Positive surprise. Now, at the demand side, because of the fact that for some applications, there are real challenges. For instance, if we look at the batteries, the fact that the NMC batteries are costly and have been exposed to high prices of the metals that are contained, you see that there is changes happening that, like, we see substitution. Substitution by the LFP batteries, for instance. And you see LFP growing in share, and because of that, like, the demand of lithium going up very, very strongly. Or if you look at the engines, the motors, the use of rare earth, which we know is constrained and especially, again, geopolitically complex, you see that people are looking for solutions that don't require rare earth to be used. And you see there again that the announcements from OEMs, from suppliers to OEMs, on, like, alternatives to rare earth applications, that this is increasing. The same thing also for electrolyzers and iridium. You get the point, is that, you know, innovation, R&D, right, is of course trying to find also solutions to get supply and demand with each other in balance, right? It's not only like, if we have higher demand and it's very costly, let's put more supply, right? It's also like, can we be more efficient at the demand side? Can we also look for alternatives? Overall, when you go back to a bit the broader definition of materials, and I have included here also thermocoal, obviously over the longer period of time, we will see that coal demand is going to go down, right? In Europe, there's only 2 countries left that are still pushing through, right, coal usage and mining, especially. For the others, when you look at it, the demand is going to remain quite strong, right? You can actually see this is in absolute terms, that for the different metals there, you see that if you take the last 10 years in absolute increase and the next 10 years in absolute increase, that the next 10 years will be at least the level of the last 10 years. In most cases, a little bit higher, and especially lithium is an enormous increase of the delta, the absolute increase of lithium demand, right? Then, as I told you before, it's of course important to look at, like, the supply-demand balance, right? And we have here a view on the 2035, so 10 years from now, the 2035 demand-supply balance. And what you have here is the current perspective, 2024 perspective, with everything that was available of different materials. And of course, you can see there the darker red, the bigger the unbalance, right? That means that the supply is not enough to meet the demand. And you can see that especially for rare earth, for sulfur, uranium, we are seeing in the base case still a significant lack of supply in 2035, based on what is announced, based on what is deemed feasible for now, right? Now, of course, if you push it, and that's at the right-hand side, there is more projects that could be coming on stream. Currently, unlikely, problems, feasibility, this and that, funding sometimes also more practical problems. You can see that, like, the pipelines in general are better, but for several of these commodities, for these materials, there is a need to accelerate the development of supply. You can also see with the arrows there at the left-hand side that compared to previous assumptions, that in some cases, for instance, in nickel, the gap is closed. Cobalt, the gap is closed. So when in the industry there is a consensus that there is a certain gap, of course, this attracts typically investors. This attracts companies to come with like plans. And as I showed you before, sometimes quite agile, faster than we would have expected before. So overall, the summary of this is that in the whole group of materials, there's materials where there is a gap, there is materials where the gap has now recently been closed, and then there is some things in the middle where it's a smaller gap and where maybe we will see positive surprises. So if we are now thinking about the future, obviously, what I have been showing you as examples will all be necessary. It will be necessary at the supply side to look for further exploration, right? To look for also ways to be more efficient. To standardization, modularization are all things that can help us to reduce risk, to reduce complexity, to go faster. But we know that in some parts of the world where we want to see more capacity coming on stream, that there will be a need to think about water availability. There need to be a need, for instance, for power, right? Like in the copper belt in Africa, right? Power is actually the biggest bottleneck to be addressed. At the demand side, I've already explained that there is a need to think about, like, what kind of like new technologies that are maybe more efficient, that require less of constrained materials. The same thing, of course, with the process side. And then on the policy dimension, it's important that policies are bringing stability, are bringing certainty as much as possible for investors, right? We have a very uncertain, a very volatile world. And so policies need to help us, right, to accelerate and to bring the stability to fuel investment, to support investment. Policies also need to be, as simple as possible, right? We want to avoid that, like red tape, all kinds of complexities are actually slowing down exploration, slowing down the development of projects. Now, this is not easy, right? Because there is like multiple stakeholders. There is also a lot of dimensions to be considered, right? Not only the pure business dimension, there is also social dimensions, environmental dimensions, the trilemma that I talked about. All these dimensions need to be considered. Now, one thing that is very important and that obviously will be critical to get right is at what kind of price of these different materials and commodities where we have a gap will the price need to be to ensure that people are incentivized to build new capacity, right? To work on the supply side. Right? And what you can see here, these are the cost curves of announced projects for nickel, for lithium, and for copper. Right? So the more you go to the right, of course, the more capacity will come on stream. But also, we have like ordered this as a cost curve. This is an investment curve. This means that like the more you have to go to the right, the more you get on stream, but also the higher the price to incentivize that capacity to come on stream, right? So in blue, you have the price mid of 2024. Then black is the minimum price to meet the 2035 demand, assuming that like all these projects will come on stream. No delays, everything goes fine, as expected, all good. Of course, if I assume 80% of what in the black line would come on stream, only 80% comes on stream, I need to push a bit more, right? I need to fill the pipeline with more so that like I can take that haircut of 20%. So that will, of course, drive the price up. And so you can see that we may have a need to increase the price by 40%, by 50%. So current price levels are actually too low to incentivize what we need for 2035. That's business, that's pure business. This is not policy, this is business. On the practical side, obviously, operationally, we will want to see very high capital expenditure efficiency, right? We want to make sure that the design of these new projects is such that like we get the maximum value for the investment that we make. So the design needs to be good. The infrastructure that like goes with the mining, we need to make sure that we have the right infrastructure. We need to actually also maybe see how we can work together between different projects, maybe between even countries. If you, again, Africa, the Copper Belt, like between different countries there, how can there be some collaboration on infrastructure, right? So that like we have the highest possible efficiency of the investments that we make. And then also on the ramp up, because we see that a lot of these delays that we observe, these delays are because we are suffering from operational issues during the ramp up. So how can we also make sure that when we ramp up, that we have the right incentives for our own people, that we have the incentives for our contractors to go faster and be more successful in ramping up to the capacity that we are expecting, right? So overall, and you see some examples there of companies that have done certain things. It is very important that, you know, end to end, every step of the chain is well covered and is efficient. So the third dimension is the sustainability dimension. So we don't only want to have available materials and affordable materials, but we also want to have green materials. And what you can see here is that the emissions in 2023, actually there 88% of those emissions are the steel value chain, thermal coal mining, and the aluminum value chain. So almost 90% is coming from steel and aluminum value chain and from thermal coal mining. Right? Now, what you can see is that what currently is in the making for 2035 will not give us an incredible decrease, 15% reduction of the emissions compared to 23, 15% by 2035. You can see that for the demand, it's more or less zero. Renewable energy will reduce 5%. Improved circularity, so scrap and reuse, another 4%. Efficiency improvements, 4%. So these are the big buckets. Now, what you can also see is that the reduction of the steel, aluminum, and thermal coal value chains will be the biggest, right? So that's why that 90% goes to around 80%. What that means is that the new metals that come in, the battery materials, right? They are not very clean. Nickel, for instance, right? Compared to steel, has a footprint, right? That is like times 15 on CO2 per ton. So there is real work to do also on these new materials. And this what is a bit in this complicated slide. You see there again on the top, steel, all the way to the battery materials, and then different levers that we can pull. The good news is that there is a lot of technology already available today, right? And it's proven. So our issue is not like, do we need to wait for new technology to come? Our issue is actually much more, is the technology already in the money, and I'll say something about it immediately. But overall, we can, and that's the abatement potential. You see these white percentages. We can abate quite a bit of the CO2 that is coming from these materials. Technologically, not a problem. But what you see in the bottom, and that is very important, this will increase the cost. Right? This is not coming for free. And the question is there a business case? Who is going to pay for it? So that's what we tried to find out when we did a survey last year where we asked people in the industry, and we asked people in steel, in aluminum, in copper, and we say, how much are you ready to pay? How much are you ready to pay? And let me take the steel example. So what you see there is in white, 11%. What that means, and you see there in the bottom, 100. So that means $100 per ton is what 11% of the people that we asked are willing to pay. Right? So, or you can say only 11% of the people are willing to pay $100 per ton. Okay? Then 42% of the people are willing to pay $50 per ton. Overall, the weighted average of this, $30 per ton, right? So the weighted average is like the people we asked are willing to pay for steel $30 per ton. That's a global number. Now, let's see what that means. What I show you here is the situation in 2023, right? So if we want to go in Europe, European example, let's say flat steel, currently made with blast furnace. If we want to go from the blast furnace in Europe to EAF plus DRI, natural gas-based DRI, not hydrogen-based DRI, the first bar there, natural gas-based DRI. We need 75, in this case, dollar per ton covered. 75, yeah? Think about it again. What percentage of the people is willing to pay that? 20%, right? It's a bit of the mathematics and so on, but like 20% of the people are willing to pay the 75. Okay, 80% not. If you look at it, the extra cost of hydrogen-based DRI is completely prohibitive, right? It's $330 per ton. Nobody wants to pay this. Okay, what do you see in Europe? Some people have announced hydrogen, but people are starting in Europe to say, oh, maybe a bit later, maybe I'll start with natural gas, moving to the left. Some people saying, oh, but even natural gas, I'm going to delay. Why? Because 80% doesn't want to pay for it. Now, let's go to 2030. Now, the only difference in 2030 is actually that then we will have the CO2 tax really being paid. Not 100% yet, not 100% because there's the ramp up until 2034. But in 2030, of course, people are already going to pay CO2 tax. So this means that actually the cost is in any case going to go up. This means the extra cost for the natural gas DRI is of course down compared to the reference that is up. 85% of the people are willing to pay that $10 that needs to be covered. So this is what you see happening in Europe. People are saying, let's delay, let's not go fast, because there is no business case until 2030. And for hydrogen, even longer out. So this, in the end, brings us to the summary of all this, is that yes, we need availability, affordability, and sustainability of the materials. What are the different dimensions in availability? We need to look at like what kind of products are needed, what kind of value chains are needed. How can we collaborate more with ecosystems? We're going to move now to the panel. We will talk more about that. Then also, we need to be efficient. The more we're efficient, the more we can do with the same investment in the CapEx, the more we can do with the same OpEx, with the same efforts that we do in processing. And finally, we need to keep on finding business cases for making these materials green. It's not enough to have technology, right? We need to have the business case. We need to have happy investors to do this. So I'm going to hand over now to our chair of the panel, William, please come up, and I will join the panel, but I will listen carefully to your questions. Thank you very much.